Welcome friend. Today I am going to discuss on Principal Component Analysis or PCA. If you are going to work on data science or work on messy, analyze the messy data set, PCA is a very important thing. You can say superpower. So PCA understanding is very important. Let me explain the PCA step by step. So before start, yes, I want to say that many people may know that the PCA is just actually the process to um, reduce the dimension of the data. Dimension means the number of features or column you can say easily you can understand. But you have to know why we need PCA, when to use is also crucial. Here in this tutorial, mostly I will discuss, give you example based on our house pricing data set, and sometimes also may take example from the student marks data set. Okay. So first, let me discuss the business problem PCA solves. Imagine a house price data set. In data set, notice that here area increase, also bedroom and bathroom increase, right? This means some information is duplicate, right? You can say redundant. If we take care about the area, then in that case bedroom or bathroom don't need this both, right? If area increase, obviously the bathroom and bedroom also increase in many scenarios. So actually goal of the PC is convert the area, bathroom and bedroom into a PCA1 and PCA2 while preserving most information. Actually, PC1, PC2 may be confusing. Actually, what PCA does, that is, it converts the common, redundant feature into a new feature called principal component. And based on the priority, I mean, percent of variance, it creates a PC1, PC2 kind. And that means principal component 1, principal component 2, like this. So PCA actually reduce the number of uh, columns or in features or dimension, but it preserves the most information. Preserve or not all the information, but most information. That means some information we may lose. So we need to mind it. Okay, I will discuss this thing later. So PCA looks at the data and tab. So why keep 3 columns if they all describe house type? Actually, talking about the area, bedroom, and bathroom, right? Because you can see area, bedroom, bathroom increase, price also increase, right? area increase, price increase. And also area is, if area is increasing, also bedroom and bathroom increase, right? That means three columns are redundant, right? So what it does is create the principal component one first. It's the biggest pattern. The biggest pattern is overall house size. Instead of looking at individual stats, we realize area, bedrooms and bathroom all dictate size. Right? We realize, so large positive value equals a very large house, large negative value equals small house. PCA one equivalence of house size score. And then principal component 2 is finds the second highest pattern. For in this example, we may say it's a house layout style. So what if two houses have 2000 square feet, I mean same, but one has 2 beds and another has 5. So space is arranged differently, right? That in positive value equals to spacious layout, and here negative value indicates the many small rooms. So PC2 equals to equivalent to layout score. So in this way, it creates multiple physical components. Usually we take 100. It's a standard practice. 100 physical components. So why PC exists? As I said, modern datasets have hundreds of to thousands of features. For example, for healthcare, we have approximately 500 different features or columns. In genomics, surprising, it is 20k plus features. So this causes major problem that PC solves. For example, storage and memory. Okay? So large feature set consume massive amount of memory, definitely. So PC actually compresses the data and requiring only the significant less storage, because it only retains the important, I mean, the merging the similar type of features into one new column, that is called PC. That means it reduces the size of data. Then computation speed, definitely. Whenever you actually train your model, if the feature is more, then it slows your model training, right? So PC actually drastically improves the or accelerates the execution, because as I said, it will reduce the dimension. Next is noise and overfitting. Many features contain useless information. So too many features cause model to memorize it, right? That's why PC is important. It removes the noise by removing the duplicate redundant values. So PCA creates principal component. It takes a simple question to find them where is the variation high. Why? Because difference actually indicates that there is some information. For example, if student marks are exactly around 50 or all are same, can you guess any? I mean, it will help you to understand deduction from the marks of a class, student marks of a class? No, because there is no variation. So all students are same category. So that means there is no question or other information. It does not indicate actually overall status, right? So fundamental PCA assumption is higher variance equals to more information. Higher variance means variation of the data. But here in this example, there is no variation. All are around same, all are same value. So main actually working principle of the PCA is to finding the direction where the highest variance present. Imagine plotting student score for math versus physics. We can say the data is like this math physics, math physics, right? We can take this example. Okay? So, since the student good at math are often good at physics, the points from diagonal cluster. Yes, in the right side is diagonal. So most variance happen along this diagonal direction. PCA mathematically finds the exact diagonal line, and this line becomes the principal component. Okay, one. Okay, so PCA will be the direction within the second highest variance, orthogonal to PC1. So like this way, PCA works. Yes, I mean one mandatory thing is that before PCA, feature scaling is mandatory. For example, area range like 1000 to 10,000, for example. Bedroom range like 2 to 5, maximum maybe 10, not more than. So their value is very higher range value and very lower range value. As I said in the previous example as well, tutorial. So if you train with this data, the model, sorry, if we apply PC on this data, so PC incorrectly assume the area is a most important feature because of the large value, right? So before PCA, we need to scale our data or standardize our data so that it the value become from 0 to 100. So all the columns value should be looks like same. Now if we apply the PCA, it will work and be a correct. This is the formula finding the gate score standardization. Okay, we already discussed in the previous tutorial one of the technique of the standardization. So the flow of the data science we can say, I mean PCA. So first I will need to load the data, then I have to scale the features. That means features means to standardize the value. Then we have to apply PCA and then check the variance. Okay. You can see the graphical way how PCA actually uh, works. I mean, PC1 you can say 60% of variance, PC2 25% variance, PC3 10%, and remaining the 5%. Okay? I mean, you can say usually basically our loss information, we actually discard the some feature, and this actually you can say the loss of information is around 5%. So maximum important value actually exists only around 5% or below 5% information loss. Less important information loss. So graphical overview how PCA works, how we choose or create new feature. Is the technique. Application of PCA, yeah, in computer vision, image compression and face recognition. Because in here, reduce the thousands of pixel dimension into a manageable set of code. In finance and fraud, stock market analysis and fraud detection, it accelerates the main drivers of the market movement and reduces noise for cleaner signal. Healthcare, as I said, because in genomics and bioinformatics, complex area of 20k plus genes to find underlying biological pattern and traits. Now, when to use and when not to use this? What's important? We learn PCA, that means everywhere we will apply. Actually, not. We should apply only when we actually need it. So when to use? You have too many features. That means this is causing memory in that case, which is highly correlated. You need faster training, you need visualization, because if we have reduced number of dimension, then it will help to plot the data in the 2D or 3D. You need noise reduction in the data set, and when not to use, the data is already small. Definitely we should not apply. And interpretability is crucial, because if you not really understand the thing, also it will be useless, right? So area and bedrooms is easy to explain for the client, right? But if we use PC and PC2, no sense, right? Now the business user need exact explanation of features. In that case, we need we should not apply PCA, because if I use PCA, definitely some information will be lost. Less information, less important information will be lost, as I said before. Advantage of the PCA: reduce dimension. As I said, it massively shrinks the data set size. Faster training, reduce noise and overfitting, handle multi-correlated. And disadvantage: hard to interpret, because as I said, it will get new features in PC1, PC2. It's hard to understand. Definitely information loss is also the problem. Weaker scaling is very important, as I said before. And definitely it will not always give you the benefit, exact benefit, right? So that's all for today, and please go through